Start recording. All right. There we go. Better. Now, let's go through from last day. We had our observation and inference on page 61. Let's go through those ones together on page 61. Where is it? Oh, there it is. 1.3F. Okay. All right. So from that picture that we looked at, is it an observation or an inference that the time of day in the cartoon is unknown? Yes? That is an inference. Let's go look at the picture because I've forgotten. Yeah, according to the picture, we have no idea what time it is because there's nothing in the picture to tell us. So that is an observation. The person in the picture is wearing shoes and socks. Yes? That is an observation, unless you could argue another way. You could say he's wearing that person is wearing an ankle bracelet. Right? So you could argue it that way if you wanted to. But I think the fact that you've said observation is a good choice. Okay? I think observation is a good choice. The person pictured is a man. I want someone I haven't heard from yet. Yeah. That is an inference. Yes, absolutely. Because we look at it and we're like, okay, hairy legs. But I'll be honest with you, I have blonde hair on my legs. I'm really, really lazy about shaving my legs. I hardly ever bother. If you were to come up and look closely, which would be weird, right? So that's why I don't bother, because I'm like, if you're looking that closely at my legs, that's just strange and you should stop immediately. But they're like, yeah. Because I just don't care that much. I'm old and I don't care anymore. Yeah. So, and the legs are fairly straight, which might be more indicative of a man, but again, who knows? There are women with straighter calves and there's, men with more, what do you call them? Diamond shaped? I don't know. Anyway, different shaped legs, depending on who the person is, not just their gender. Okay. The chin-up bar is set too high. I want someone who has not talked to me yet. Yes. That is... I would actually argue that that's an inference.
What if you know exactly how high the chin-up bar is supposed to be? You can look at this and be like, oh no, that's too high.
Yeah. But I'm not directly observing that the chin-up bar is too high because I don't even know, how did that thing get broken? He probably hit his head on it, yes? But what if it was like that before he got there? And he's just lying down to take a nap on the floor. I don't know. As a parent, when I had my little son and he was like up all night, I would like lie on the floor because I was just so dang tired, right? When he was a little one, I would go, oh my God, I need to sleep. Please let me sleep, right? I would lie on the floor because I was so tired. So I would say it is an inference that the chin-up bar is too high. It is a good inference. You have used all your powers of observation and your logical deduction to make an excellent inference. That is a very likely inference, but an inference nonetheless. The chin-up bar arrived in one package. Observation or inference? Yeah. Inference. We see one box, but what if there's another box on the other end of the couch, right? So that is an inference. The person pictured has less than 20/20 or perfect eyesight. Yes. That is an inference. What did we use to infer that he has less than 20/20 sight? Yeah, it looks like there's some glasses down at the bottom there. Okay. The person is lying on their back. Yes. Probably. Anyone want to argue inference for me on that one? Aria? He could be sitting. That's true. He could be sitting, and we just can't see his body. It could be. Did you have another one? Or you had the same one? No. Okay. It could be a mannequin. And it's just the legs. I don't know. I can't tell from the picture. Yeah, those could totally be fake, right? Like, be anything, right? All right. So that's an inference, although it's a very good inference, okay? But just because something is a really good inference, just because it appears completely obvious, doesn't mean it is actually an observation. If you can't see the whole picture, then you cannot observe that particular thing. Yes? The next one, the person has sustained an injury. That is an inference for sure. Okay? I'm assuming this man has bonked his head on the top of the door, knocked himself out, and is now lying on the ground. And you notice I said him because I'm assuming it's a man, right? But all of those things I am inferring. The person is a teenager. Yes. That is an inference. We have no idea. The frame of the glasses is bent. I would say that's an observation, yeah, because, it's like looking bent. Okay, we can see it. This was the first time the individual had used a chin-up bar. That is an inference. And now you get to be a little bit more brave if you want to volunteer for these ones, because you have to say a little more than one word. What's an observation that's not one of these ones that you could make about that picture? Yes? The door frame is broken. Yes. You can see that. Anyone want to make a quantitative observation? Let's look at the picture. See if you can make a quantitative observation. Yeah? There's 8 leg hairs on the left leg. Let's count. On the right leg. 1, 2, 3, 4, 5, 6, 7, 8. Correct. There are 8 leg hairs on that right leg. Quantitative observation, 8 leg hairs on the right leg. Does anyone want to make an inference that's not there? Ryan?
The person is dead.
The person is dead. Yeah, you could infer that. It's totally possible. Is that as likely an inference as the person is lying on their back?
No.
Probably not, right? It's probably more likely the person is lying on their back or that they've sustained an injury than that they are dead, because people don't generally tend to just die from bonking their head, although that looks like a pretty severe bonk. I mean, honestly, if you've broken can you imagine how much force it would actually take to break a door frame? Maybe he would be dead. Maybe that is a good inference. I don't know. I don't know how much force you'd have to lift yourself with. That would be crazy.
When I wanted to see if he could break the frame.
Yeah, exactly. I don't know. All right. And if you did these last day, that's great. If not, we're going to fill it in together. Okay. So we have 3 different inferences. We're going to create 3 different inferences to explain why that person is lying on the ground. For each inference, provide 1 supporting piece of evidence. Who's got 1 inference as to why this guy is lying on the ground? Yes.
He attempted to do it and up, but then the dust from the cracking of the thing fell into his eyes and then he fell down.
Oh, I like that. He attempted to chin up, but the dust from the broken door frame, we're assuming here that the door frame was broken beforehand. I like that. That is an interesting inference. From the broken door frame, got in his eyes. And that made him fall. And your evidence for that?
There's a crack above the center of the bar, and I think people have it that up the inside of the bar.
Yeah, there's a crack above the center of the bar. If you can't read anything that I've written, just let me know. I can make it better. Yes.
How did it have gone in his eyes if he has glasses?
You'll still get things.
You can still
You have glasses.
says a person with glasses. Yes, it's true. You can still get things in your eyes with glasses.
Okay.
Yeah, because I've gotten stuff in my eyes with glasses. That's why if you're doing something, you would put on, like if you're actually doing something where you know you're going to get dust, you can put on safety glasses. Okay. Someone got another inference as to how that person ended up lying on the ground. Yes.
The man tried to grab the door. He tried to grab the door, like how I saw on the
Yep.
that in the door, and then they lost their grip, so they tried to grab the door.
They tried to grab the door frame when they lost their grip?
Yeah.
Okay. Okay, your evidence for that? There's a crack in the door frame.
And there's also pieces on the ground. It looks like something tore down.
There's pieces on the ground. Okay. Anyone else got another inference as to why that guy ended up on the ground? I'm just going to wait till people finish writing. Spencer.
Okay, so he is running his house
Yep.
and really tall.
Yep.
It's not on the door frame,
Okay.
but as he's falling down, the bar has got glasses.
Uh,
They're flying and falling.
okay, so the guy's really tall. Tall guy. Very tall guy. Running in his house. All right. And he smacks the door frame with his head. And In the process, his glasses catch on the chin-up bar. And he falls down. Is that the general gist of it? Okay. And your evidence?
Like, fall down the back.
Mm-hmm. Yep. Yep. So he's falling backwards. Glasses are on the floor. Yeah. I'm probably not getting everything you had there, but good enough. Now, if you had to pick one of these, which of these three is the most plausible? Feel free to write down anything and then take a look and decide which one do you think is the most likely. Or you can say none of them and come up with one of your own that sounds more likely. Anyone want to choose one?
Should do a vote.
We should do a vote. Okay, so we got number 1, number 2, number 3. And you can also vote, I don't think any of those are very likely, and I would like to come up with a different inference that's the most likely. Okay, so 4 is none of the above. And we're going to learn sign language for the numbers, which is actually really easy. So we got 1. Okay, super hard. 2. Now, 3. And the reason it's probably like this is that this is A, this is a W. Okay, but also this is a harder position to hold than this. Like this just is easy to hold as opposed to 3. So it goes 1, 2, 3, and then 4 is just back to normal. Now, if you do 3 like this, nobody's going to get mad at you. I'm not going to get mad at you, but if you want to know the actual way of signing it, it is 1, 2, 3, 4. So pick which one you think is the most likely, and I'll count down from 5, 4, 3, 2, 1, and then we'll vote, okay? So think about it for a second. And we are going to 5, 4, 3, 2, 1, vote. All right, I got some 1s, I got some 3s, I got some 4s. Okay, and I got some 2s. So I got everything really. Okay, so that's going to be a judgment call on your part. All right, so that's good. All right, based on the cartoon, write a research question that could be answered in an experiment. Now, usually a research question is trying to solve a problem. So let's look at our picture and see if we can think of a problem that needs solving. You can have a little chat with your neighbor about that. See if you can think of a problem that needs solving.
How high is the chicken?
Okay, most likely, what is our problem here?
The chin-up bar is too high.
Probably the chin-up bar is too high. So what could be a question that we could investigate that would make this safer so we didn't have accidents like this? And you can have a little chat about that. How could we make it safer so we don't put the chin-up bar too high? What question could we ask ourselves and do some research on, do an experiment about? Yes.
How high should you set up your chin-up bar?
How-
Your door frame?
Yeah, how high relative to your door frame should you set up the chin-up bar? That would be an excellent research question. Then you could solve that and put it in the instructions. Or maybe there are instructions and he just didn't read them, but.
For security.
So we could say how far below the door frame should the chin-up bar go? Okay, very good. Do we need a brain break? Yes? Okay. We have a choice for a brain break today. We can either go do the parking lot again. No bonus marks this time, though, because can't have bonus marks every single time. Or we can do some cross-body motion and stretches. Parking lot? Cross-body motion and stretches. Parking lot it is. Okay, let's go around the parking lot. See if you can do that. That's amazing. I'm going to be out of shape 54-year-old woman. Right? You can't make that before you know life.
I feel bad for that seal. Like that.
Okay, we are going to take a look at this triple beam balance here. This is on page 28. Page 28.
I think I know kind of. Like we did it last time. I did it last year. I think
Now, this is a triple beam balance, and you can tell that it's a triple beam balance because you have 1, 2. Did I say what page this was on?
Yep.
Page 28. Here, let me write it down here so you can actually see it. Page 28. So we have 1 beam, we have 2 beams, and we have, I need another color, 3 beams. That's why it's a triple beam balance. The balances that we have at this school have how many beams? 4 beams. What do you think we would call those balances?
4 beam balance.
You could call it a 4 beam balance, but if we call the one with 3 triple, do you guys know what 4 is? Quadruple. So we're going to call them quadruple beam balances, or quad beam balances, okay? Because quadruple is really long. I hear you. I got your back, okay? So what we're going to do is we're going to look at this, and each of these 3 beams has a little slider. Do you remember doing this last year?
Yeah.
Okay, and the little slider goes along, and I don't know why, normally on our balances, the biggest number is at the back, okay, and then it gets smaller. In this one, our biggest number is our 500. So this is sitting at 500, okay. The next smallest number is sitting at 70. And then finally, we've got this one down at the bottom that is sitting at, well, here, okay? And we're going to have to figure out exactly what that is, okay? So we know, though, if we were to, let's say we are measuring a stapler. That's a very heavy stapler. What's something that's 500 grams? We're measuring a rock.
I mean,
what would you like?
Flour you have. I said flour.
A flour? That's a heavy flour.
Flour. Like
oh, flour. Yeah, okay, so we're measuring flour, okay? Not a flour, but flour.
Yeah.
Okay, so if we are measuring flour, and you'll notice here the unit is grams. What quantity are we measuring if it's grams? Grams tells you we are measuring mass, not weight. What's weight measured in?
Pounds?
Could be, but remember, weight is due to the
Gravity?
force of gravity. And so weight would be in newtons. Okay? So if you have weight, it would be in newtons. But because it's grams, that is mass.
So when you weigh like ingredients on a scale, it's actually
You're really measuring the mass. Even though we say weigh and we say, what is my weight? We're really not saying that. Yeah. We're really measuring the mass. Okay, so I know that I have 500. So in my hundreds position, I can put, so I'm actually going to write this out. I know I have a blank up there, but I'm going to write it down here. I'm going to say the mass. What is the symbol for mass? Lowercase m. So I'm going to say m of the flour is equal to, and I know I'm going to have something in my hundreds position. I'm going to have a 500. What's going to go in the tens position? 70. So I'm going to put a 7. And then I am somewhere in between the numbers. What two numbers am I between?
7.6.
Yeah, I'm somewhere in between 7 and 8. So my ones position is going to be 7. So it's 577 point something. And then I want you to think about this. Tell me how many decimals. Tell your partner first, how many decimals should this answer go to? How many decimals should it go to?
Yes, because like there's tiny lines. So then you have weights, tiny line, and then in between the line parts. I'm not making sense.
No, you're making sense.
It's like right in between.
So if you look at each of those little divisions, how much is each space between the lines worth? 0.1. So you should go to 1 more than that. So you should have 2 decimal places. Yes? Okay. So we are at 7. And this one here is 7.5. Which means that our little pointer is in between 7.6 and 7.7. So the mass of the flour should be 577.60. And then it's past the halfway mark, so anything after 5 would be good. If you were to put 0.63, I would say you need to look closer because it's further than halfway. But if you put 6, 7, that would be good. You could put 6, 6. You could put 6, 8. Any of those would be reasonable. Okay? Now, am I done? Is that my full answer, getting me all my 4 or 5 marks? No, what am I missing? Sig figs are going to be optional. Okay, so what are we missing? We're missing the unit. What is our unit here? Grams. And when we are measuring grams, what quantity are we measuring? Grams measures mass. What's the unit of weight? Remember, weight is the force of gravity, and so weight is measured in newtons. Okay? Weight is measured in newtons. We're not looking at weight here, though. We are looking at mass. Mass is measured in grams. Now, if you had to count the number of significant figures in this thing, how many? 1, 2, 3, 4, 5. And none of them are difficult to figure out because there's no zeros. Every single digit that's not a zero counts. So this is going to have 5 significant figures. They are significant figures. It is all the certain digits plus 1 estimated digit. So if I look at my number, all my certain digits, that's all of these ones. My uncertain digit is the 7. My estimated digit is that last 7. But if you're not into sig figs, you can just be like, that's bonus stuff. I don't need to learn that. So don't worry about it. If it confuses you, just be like, don't need it. Do you guys need another example, or do you think that's enough for that particular thing? That's enough for that? Okay. We're going to also look at this thing, which is called a, where is it? On page 30, page 30. I'm just going to grab one of these so you can see what it looks like in real life. We're going to actually use one of these either tomorrow or the next day. Okay. We're also going to use the quad beam balances, but they're really popular at the beginning of the year. Do you remember using them at the beginning of the year with your grade 8 class? Maybe those balances. So when you want to use a Buret, you're going to get a stand, just like you used when you were tying the knot. You're going to get a Buret clamp, okay? And we don't attach it like this, too unsteady. There is a place in here, okay? There's a screw that opens it up. So you can open it up enough that you can slide it on, so it slides on so it's in the middle, and then you tighten up the screw so that now you have that, and now you pinch these together, and that opens up a place where you can put the Buret. Yeah? All right. I'm also going to grab another piece of equipment. We're going to want a funnel and a beaker. All right. Like I said, you guys are doing this in the next couple of days. Okay, so I got water. I got a funnel. I can barely reach that. Does this look like a good idea? No, I am too short. Yes? Not a good idea. What if I tried to get myself higher up on my chair? Is that a good idea? No. So don't stand on your chair to get yourself closer. I'm not actually going to even try standing on this one because this one's wobbly, but you don't stand on your chair either, okay? The easiest way to fill this, rather than you going up, you bring the Buret down to you. Yes? I'm going to stand on my little step stool here so that you can actually see me better, okay? And I'm going to show you what happens if you try and fill it too quickly. All right? This is just water, so it doesn't matter. If I get water in my hands, I don't care. Oh, did it not do it? Oh, it did. Usually what it does is it overflows. Okay, if you fill it up, it usually overflows on you. And so you don't want to like pour it all in at once. You want to pour in some and then a little bit more and then a little bit more. Because if this weren't water, what would I have on my hands now? Maybe chemical, toxic chemical, an acid, a base. Now my skin is getting eaten alive. That's no good. Yeah? Once I've got it filled though, and I'm not going to worry about this water, this little valve here, we want to fill the tip with water. So we're going to open it. This is closed. Do you see how it blocks the water? Okay. Which way do you think is open? Up and down is open. Okay, so I'm going to make it go up and down. I'm doing it over the sink because water is going to come out. Okay. Some bubbles came out. And now I'm going to wait for it to get down to the part where there's lines. There's lines starting here. And I can really stop it at any point I want to after it gets down into the area with the lines. Okay? Now, what I would do at this point is I would put this back for a moment because I need to empty my beaker and I need hands-free to do that. Now, I want to actually read that value. Okay, I want to see where the bottom of the, what's the word? The meniscus. I want to see where the bottom of the meniscus is. Is this going to work well? No. What should I do? Bring it down to me, okay? Don't try and get up to it. Bring it down to you. All right? Again, though, I'm going to stand up here so it's easier for you to see. Because you guys are grade 9s, yes. Okay, sorry. Because you guys are grade 9s, you don't have to use this magical piece of equipment here. This is actually called a Buret reading card. It's super fancy. You get a card and you draw a black line on it. Super fancy, okay? And the reason I have this is that if I look at this right now, well, number one, my eyes are old, so I cannot see up close, so I have to take my glasses off, which is not the best practice when it comes to being safe in the chemistry lab. But let's just assume I didn't have to do that. Water against glass, and then it's all clear so I can see everything in the background. Do you think that's going to be easy to read or hard to read? Hard to read because everything's clear, and then it's like, oh, there's all this messy stuff in the background. I can see Sophia's face almost through this thing. You know, like it's just not really good for reading. What you can do with this Buret reading card, and I'm going to turn around so you can see it from my perspective. Okay, I'm going to put it in behind. And I've got it up above my head so you can see it. I don't put the black line at the meniscus. I put the black line below the meniscus. Whoops. The meniscus will reflect the black. If the black is down below, the meniscus will reflect. And it actually makes that line become black and it pops out at you. Okay? If you find this too complicated, though, you guys are in grade 9, you can just be like, I'm just going to look at it and do my best. Okay, that's perfectly fine. But if you want to use the Buret reading card, does this go behind the meniscus or below the meniscus? Below the meniscus. Okay, so I put it below the meniscus and I look and I say, I can see. That's beautiful. Now I've got this beautiful black line against a white background because the meniscus looks black. Okay? Now what I saw on there looked like this. So what I saw on there looked like this. Okay? And this was a 3, and this was a 4. And my water level, which looked black, looked like this. Okay? I'm going to make it even bigger so you can see it a little bit better. Now, one thing you'll notice, what do you notice about these numbers? Where's the smaller number? On the top. We actually, these things start somewhere up at the top. This is our 0 milliliters. Down at the bottom, that's going to be 50 milliliters. Okay, so you make sure that you read downward. Okay, so you read down. Burets read down. So rather than me going over to my Buret and saying, oh, this is 4.4 milliliters, it's not 4.4, what would it be? It would be 3, 3.1, 3.5, and then this one here would be 3.6. Yeah? So that's 3.6. So I would say 3.6. And I'm going to ask you if that is a good measurement. Tell your partner, do you like my measurement, or are there things that I need to fix about it? Yes. Why do the numbers go down? That's actually a really great question. Let's say I started and I had, let's say I just started at a really nice, easy number. Say I started at 1 milliliter, okay? And then say I dripped out the water, okay? So the water level goes down. I drip it out, drip it out, drip it out. And then I end at, I don't know, 48 milliliters. My final volume on my water is 48 milliliters. Why will it not draw for me? There's my final volume of the water. What I do is I say 48 milliliters minus 1 milliliter. That tells me how much got dripped out. That's what a Buret is used for, is to say, how much did I drip out? So we're not really actually ever interested in a single reading of a Buret. We're always going to have a starting volume and a finishing volume. Okay, and we take the finishing one and we subtract the starting one. And that's how we figure out how much got dripped out. And that's why it reads from 0 to a bigger number down at the bottom. What would this be? Is this a good measurement, or am I missing anything? I'm missing units. Okay, so this is, Burets are always in milliliters. So that's milliliters. Yeah. I need a 0 because each of these little doodads here, this right here is 3.7, right? Each of those little lines is worth 0.1. So I don't need 1 decimal place, I need 2 decimal places. So I'm going to say 3.0. Am I good yet? Not quite. I need that beginning thing. And I really want to redo this workbook, so you have to do that on the last practice you did, because you probably forgot about it because I filled those all in for you. What are we measuring? What quantity is being measured here? Volume, okay? So you could say volume of water, okay? Because it's water in there. Volume of water. Yeah? Equals 3.60 milliliters. So our volume of water equals 3.60 milliliters. Actually, no. I'm so silly. Sorry. Because this example is different from the actual picture. Picture's over here. We'll take a look at that one in a minute, and you guys can do that one on your own. How many sig figs in this number? Yes? Remember, if we've got our zeros, these ones here, no. These ones here, yes. These ones here, maybe. You can remember nim, no, yes, maybe. What do we need to look at to see if there's a maybe? If there's a decimal, then yes. It doesn't matter if they're in front of the decimal or behind the decimal. Just if there is a decimal. If there is a decimal, yes. If no decimal, no. Okay? And like I said, if you're not interested in sig figs, just ignore that. But it's not that hard, right? If you remember nim, and you can say decimal, yes. Significant, yes. Decimal, no. Significant, no. And we look at our ones on the end there and we say decimal, yes. So significant, yes. And what that means is we now have 3 sig figs. If this is making no sense to you and you would like it to make more sense to you, please feel free to come by at Flex on Thursday, or you can drop by after school sometime if you want to do that. But I think most people like Flex because then you don't have to stay after school, right? Okay. And what you guys are going to do for homework, and you can get started on it now, is on page, let me find the pages. Here we go. Okay.
Is it page 31?
Yeah. Yeah, so we're going to do page 28, number 2. If you have not already done it, because that's a triple beam balance. And we are going to do page 30, number 8, because we didn't really do page 30, number 8. We did our own little one. Page 30, number 8. And then on page 31, you are going to do number 9, A through D. But you can leave out the ones with the sig figs if you don't want to do those. And that's it. Okay? And tomorrow we'll talk about the calculation on page 9. Or sorry, on page 31.
Okay. I like the cold. I just like the cold. Yeah, I like I mean, I like the cold over the heat for sure. It's like wearing it. I just want myself. I don't want to this is what we Oh, there is flex tomorrow. Yeah, there is. I forgot. I thought today was Tuesday. There is flex tomorrow. So if you're interested in learning about if you understand the homework, you have trouble with it, drop my flex. Okay? This needs to get filed on that. No, I like it. Like, explain it first again. Do it. No, you have to keep. If you've not yet, oh wait, I forgot to get my phone. They get your phone. You can take a picture of the homework if you want, but it will be on Teams. Yeah, always text me during class. Thank you. Oh, today I want a copy of the enriched stuff. Not get one. All right. Sample this and good to go. Those and those. Sorry.
I mean,
Okay.